Swayam Prabha. Digital India. Educated India.
So in the last module, we saw how you open R files and work with them. The key aspect of R is handling data. So what we are going to do in the next module is to look at the types of data that R can handle and how do you process those data and work with them. The basic data types are the following. You could have data that is logical, which means they could take values true or false. You could have data type that is integer, which is set of all integers. Numeric, set of all real numbers. You could also define a variable as a complex variable, which would be set of any complex numbers that you are interested in. And you could also have character type, which, as seen in the screen, could be any character that you can use as a data type. There are several things that you can do with the data type. In this slide, what we're going to show is a table which talks about the tasks that you can do, and then the syntax for that. So if you want to find the type of an object, the action that you should do is type of. Okay? So the syntax is whatever object for which you want to find the type, you simply say type of that object. The second task that we can talk about is if you want to verify if an object is really of a certain data type, then you can ask the question, is data type object? For example, you could say, is integer some variable? And if this variable was originally defined as an integer, the result will be true. And if the variable was originally defined as not an integer, the result will be false. You can also do another interesting thing, where you can coerce or convert data from one type to another using ask command. So for example, if you take a variable which is numeric, you could say as.logical that variable and assign it to another variable. The new variable will be the logical type. So there are sample codes for each of this using is character, type of, and as.numeric below, in the slide below. Now, there are more complicated objects which are composites of the basic data types, and we're going to list three. These three are very important object types that are used in the algorithms that we will see later. Vectors are ordered collection of the same data type. So for example, you could have a vector of integers, you could have a vector of numbers, you could have a vector of characters, and so on. If you want to go a little more complicated, you can define what are called lists. These lists are ordered collection of objects themselves, and these objects could be of different types, and you can put them all in a list. One very interesting type of object in R is the data frames, which is used quite a bit in our data analytic algorithms. This is a generic tabular object. Typically, many of us are comfortable with matrices, and in general, matrices are in a tabular form with numbers. What data frames does is it puts the same information in a tabular object, but interestingly, each of these columns in this data frames could be of different types, as we will see as we go along in this module. So let's start with a vector. Let's see how we define a vector. As I said before, vector is an ordered collection of basic data types of a given length. The key thing to note here is all the elements of a vector must be of the same data type. So you cannot mix an integer with a character and so on. So you see the code here where we are defining a vector x, which basically says combine these numbers to make a vector. The command C, it is saying 2.3, 4.5, 6.7, 8.9 are 4 numbers which we have put into the vector x. And when we say print x, you see 2.3, 4.5, 6.7, 8.9. And you notice here that each of this number is a numeric number of the same type which has gone into the vector x. But as I mentioned before, list generalizes this concept. It's a generic object consisting of an ordered collection of objects. Because it is an ordered collection of objects, each of these objects could be of different form. And we see that in this example here. So we start by defining ID, which is basically a vector, because we see that it is C1, 2, 3, 4. So 4 integers 1, 2, 3, 4 are defined as a variable ID. Now the next variable that is defined is emp.name, which now is again a concatenation of not numbers but of strings. So you have within quotes man, drag, sha, din. The third variable we are defining is num.emp, which is just one integer. So as you see here, we have a collection of integers, we have a collection of strings and a single integer. We can put all of them together into the same structure, which is called list. So we say emp.list, and the command is list id, emp.name, num.emp. So basically what has happened is all of these three variables are stored in the same structure in a list form, and when you print this list, you see the first element is 1, 2, 3, 4 vector, the second element is your character strings, and the third element is the integer that we have defined. Now once you define a list, you can name each of these elements so that it becomes easier for you to access them later. So the same example before, instead of just saying list id, emp.name, num.emp, what we have done here is for each of these variables, while defining the list itself, we are also defining names for these variables. So if you look at this command list, within double quotes id is the name we have given for those 4 integers 1, 2, 3, 4, and names is the name we have given for emp.name and so on. So here not only are we defining the list, we are also defining identifiers for every one of the objects that we have defined in the list so that they can be easily retrieved and worked with. So for example, if you look at the right hand side of the screen, if you say print emp.list, which was your list, and since we have already named some object as names, if you put $names, it will give you back the 4 names. So this is a way to nice and easy access to the elements in a list. Now there are other ways of accessing the elements also without names. The syntax is very, very simple. List has several objects. Let's say it has 10 objects. If you want to access any one of these objects, the first level access is through 2 double square brackets that we see here. So if I say emp.list 2 double square bracket, then it will go to a particular object, and then within that you can pick anything that you want. So to give you an example, print emp.list within double quotes 1 followed by 1 would give you the corresponding answer, that particular aspect of the list object that you have defined. Now you can also manipulate these lists. So once you define a list, you can also modify by accessing components and replacing them. For example, you can add more components to already defined objects. You can add more objects to the already defined list and so on. So in this case, we are adding another object which is emp.list, which is total staff equal to 5. We could also add more names. So initially in our list we had only 4 names. Now we are adding a 5th name, which is emp.list 25, which is a new name that we are adding, and so on. And when you print this, you will see things have changed from the previous list. So this is how you can modify and access components. You can replace them too. So for example, so once you define your list, there are other ways of accessing objects in the list without identifier names. So in this example, we had these 4 objects. So if you want to identify only one object, you could use this command here, print.emp.list1, which basically gives you 1, 2, 3, 4, the 4 integers that we had defined before. And for example, if you did 2, it gives you the 4 names that you have defined before. Now, if you really wanted to actually pick out the 1 among the integers 1, 2, 3, 4, then that is 2-level access of the list, in which case what you should do is you should access the first level using 2 square brackets, and the subsequent level with a single square bracket, which is what you see in this slide. m.list with 2 square brackets 1 would refer to 1, 2, 3, 4, and when you put another square bracket 1, it refers to just the number 1 that we wanted to access. Similarly, when you do m.list 2 and you want to access man, the first level access is the second object in your list, and the second level access is the first entry in that object, which is man. Now, you could also manipulate lists. You can add, you can replace, and so on. For example, we didn't have this category before, but we can add a new category called m.list total staff equal 5, and you can add another name to the object, which is m.list 25 new name that has been added. And once you print, you will see here, initially we had only 4 names, man, drag, shah, din. Now nir is also added, and the total number of staff is 5. Now when you have multiple lists, it's very easy in R to concatenate them. So the command is simply the same command C, just put the list that you want to concatenate in sequence, and you'll get a result which is a concatenated list. So for example, if you have a list with ages 23, 48, 54, 30, 32 are shown here, you can concatenate that with your previous list by using the simple command C, m.list, m.ages, and you see the result. The ages are also part of the list. Now we go on to the next object that is used quite a bit in data science, and this is what is called data frames. And as I mentioned before, the difference between data frames and lists is that the data frames are stored in a tabular form. So that basically means you have to have the same number of columns for each row and vice versa. But unlike a matrix, an interesting thing that you can do with data frames is each one of these columns could be of different types. So here we have the first data frame that we are defining. In this case, we are defining 3 different columns. Okay. Notice that each of the column size is the same. Each column has only 3 elements, but you would see the first column is an element integer. So you have 1, 2, 3. These are the 3 integers which belong to the first column. The second column is string, which is R, Scilab, Java. Basically the size is 3, but the type is different. And the third column is again a different string type, and you can put all of them together and you have a data frame. So you might want to think of this as a tabular form where you can put disparate object types together. The only thing you have to make sure is with one vector, all the object types are the same. So this is the basic idea of a data frame.